For decades, Moore's Law defined technological progress, a doubling of transistors on a microchip every 2 years, driving the exponential growth of computing power. But what if that era is coming to a crashing halt? Not because of limits, but because something else is vastly surpassing it. We are witnessing the dawn of an entirely new computational era, where a phenomenon known as qubit growth is shattering every benchmark Moore's Law ever set. This isn't just an upgrade, it's a seismic shift, an explosion of processing potential that's rendering our classical understanding of computing obsolete. Forget the incremental advancements you're used to. Quantum computers are scaling in ways previously unimaginable, promising a leap that will redefine intelligence, problem-solving, and the very fabric of our digital existence. What if the computer you use today is destined to become a relic of a bygone age, superseded by machines that harness the fabric of reality itself? The race to achieve quantum advantage is not just theoretical. It's happening right now, at speeds that will astound you. Stick around, because the future of computing, or what we now call NextGenComputing, is more mind-bending than any science fiction story you've ever encountered. The digital world is about to be utterly transformed. So how can something so fundamentally different achieve such power? It all comes down to two seemingly impossible concepts: superposition and entanglement. In classical computing, a bit is either a 0 or a 1. It's definitive. But in the quantum realm, a qubit, the quantum equivalent, can exist as both a 0 and a 1 simultaneously, a state we call superposition. Imagine flipping a coin that, while spinning in the air, is both heads and tails until it lands. That's a qubit. This incredible ability allows quantum computers to process a vast number of possibilities at once, fundamentally changing how calculations are performed. Now add entanglement. This is where two or more qubits become mysteriously linked, sharing the same fate, no matter how far apart they are. Changing one instantly affects the other. It's like having two truly identical spinning coins. No matter where they land, if one is heads, the other is tails. Instantaneously, with no delay. When combined, superposition and entanglement allow quantum computers to explore an astronomical number of solutions in parallel, far beyond the capabilities of any supercomputer on Earth. This synergistic power is the true secret behind the coveted quantum advantage, unlocking pathways to solve problems that are currently impossible, and forging the path for entirely new forms of next-gen computing we can barely conceive. This isn't just theory anymore. Incredible advancements in quantum hardware are moving these abstract concepts into tangible, powerful machines. For years, one of the biggest hurdles was keeping qubits stable and error-free. Their fragile quantum states are incredibly susceptible to noise, like a gentle breeze knocking over a house of cards. But recent breakthroughs in quantum error correction are finally changing the game, allowing quantum systems to maintain their coherence for longer and correct intrinsic errors, making them far more robust. Think of it as developing sophisticated shields and self-healing mechanisms for these delicate quantum operations. Furthermore, the physical qubit architectures themselves are evolving at lightning speed. From the breathtaking precision of superconducting qubits, which operate at temperatures colder than deep space, to the promising scalability of photonic qubits that manipulate particles of light, scientists are innovating diverse pathways to build the foundational components of future quantum machines. We're witnessing engineering marvels that push the very boundaries of physics. These tangible developments are precisely why quantum advantage isn't just a distant dream, but an accelerating reality, propelling us into a new age of next-gen computing, capabilities that will redefine our technological horizons. So what does this abstract quantum power mean for you, for business, for the world? The implications are truly monumental. Take encryption. Every secure transaction you make, every encrypted message, relies on the current difficulty of factoring large numbers. Quantum computers can render those algorithms obsolete in moments. This directly leads us to a critical discussion about the future of encryption and the urgent need for quantum-resistant cryptography, a digital arms race to secure our information. But the impact goes far beyond cybersecurity. Imagine a world where drug discovery, once a decades-long process of trial and error, is dramatically accelerated. Quantum computers can simulate molecular interactions with unprecedented accuracy, leading to breakthrough medicines, personalized treatments, and even cures for diseases we once considered untreatable. Or consider logistics. Global supply chains, often tangled and inefficient, could be optimized with astonishing precision, revolutionizing transportation, manufacturing, and distribution. We're talking about algorithms that can identify the single most efficient route for every package, optimize entire factory floors, and predict resource needs with near-perfect accuracy. From financial modeling and materials science to AI and climate modeling, quantum computing promises to unlock solutions that were simply beyond the reach of any classical computer. This is NextGenComputing, translating directly into tangible benefits across every conceivable sector, changing how we live, work, and interact with the world. While the promise of quantum computing is immense, it's crucial to understand that it's not without its monumental challenges. Building and scaling these machines requires overcoming incredible hurdles in physics, engineering, and computer science. Qubits remain incredibly delicate, and achieving practical fault tolerance for large-scale applications is still an active area of research. Think about the complex control systems, cryogenic environments, and vacuum chambers needed to maintain these systems. However, despite these bottlenecks, the world is making massive bets on quantum. Investment trends show billions pouring into quantum R&D from venture capitalists, tech giants like IBM and Google, and numerous startups, all vying for a slice of the quantum pie. Governments around the globe are also intensely engaged in this race. National initiatives from the United States, China, the European Union, and others are injecting vast resources into quantum research, recognizing QuantumAdvantage as a critical component of national security and economic leadership. The competition for talent, patents, and groundbreaking discoveries is fierce, turning quantum supremacy into a geopolitical imperative. The next breakthroughs in next-gen computing will be driven by unprecedented collaboration and fierce competition. So when will this incredible technology truly transform our world? A precise timeline remains elusive, but most experts agree that we are rapidly approaching significant milestones. While widespread consumer-level quantum computers might be decades away, focused industrial applications achieving quantum advantage for specific problems are likely to emerge within the next 5 to 10 years. Imagine complex simulations in pharmaceutical development, materials science, or advanced financial modeling happening routinely. Beyond that, as error correction improves and hardware matures, we could see a broader integration into various sectors within 10 to 20 years. The future of encryption is already forcing immediate action from cybersecurity firms and governments, necessitating the development and adoption of quantum-resistant algorithms far sooner. This isn't a distant pipe dream, it's a tangible, rapidly evolving reality. The implications of next-gen computing are no longer confined to academic papers or theoretical physics labs. They are here, impacting policy, investment, and strategic planning on a global scale. This space is moving at breakneck speed, and staying informed is no longer a luxury, it's a necessity. Keep watching this space, because the greatest technological revolution since the internet is unfolding before our very eyes.